Today we're going to look at quadratic models using vertex form. So we're going to start by determining an equation for the parabola in vertex form given the graph shown here. So vertex form is y equals a x minus h squared plus k, where h and k represent the vertex of the parabola. So in this graph, we see that our vertex is 3, -5. So we're going to use the vertex and another point on the graph to come up with the equation of the parabola in vertex form. So first step, we're going to use the vertex. So we're going to sub in 3 for h and -5 for k. And that gives us. Next, we need to sub in any other point on the graph. So let's say we take the y-intercept. So this point here, we're going to take as 0, -2. So our second step is to sub in any other point. And we're going to sub this point in for x and y in order to determine the a value, the stretch or the compression factor. So subbing in 0, -2 gives us -2 is equal to a 0 minus 3 squared minus 5. Next is to solve for the a value. We're going to add 5 to both sides. Remember, the 5 does not have an a attached to it, so it's not a like term with a times 9. So this gives us 3 equals, if you like, 9a. And the last step, we want to solve for a, so we divide both sides by 9, and therefore a equals 1/3. We have a positive a value, which is great. That tells us that the parabola opens up, which matches our diagram. So therefore, the equation of this parabola in vertex form is y equals 1/3 x minus 3 squared minus 5. Part B. Describe the transformations you would apply to the graph of y equals x squared in the order you would apply them to obtain the graph of the parabola shown here. So remember, we're going to start with our a value, then look at h and k and describe the transformations in that order. So starting with the a value, remember 1/3 is in between 0 and 1, so we're going to have a vertical compression. So we say y equals x squared is vertically compressed, and then by a factor of 1/3. Now we look at the h and k value. So the h is 3. Since the h is 3 and the k is -5, that means we'll translate the parabola 3 units to the right and 5 units down. And there's a description of the transformations you would apply to y equals x squared to get y equals 1/3 x minus 3 squared minus 5. Example 2. A ball is thrown from a 235.2 meter high cliff. The ball reaches a maximum height of 240.1 meters after 1 second and hits the ground at 8 seconds. Determine a quadratic model in vertex form that gives the height of the ball h in meters at t seconds. So we start by sketching the graph. So we see that the graph starts at 0 and 235.2 meters. It reaches a maximum height at 1 second of 240.1 meters and then hits the ground at 8 seconds. So that's 8, 0. So if we sketch this parabola, here is the path of the ball. Remember that the y-axis represents height in meters and the x-axis represents time in seconds. Recall that the equation of a quadratic in vertex form is y equals a x minus h squared plus k. The first step is to sub in the vertex, and recall that the vertex represents the h and k value of a quadratic in vertex form. Also note that the y value is now going to become h because we want height as the variable for y. We have a, x minus the h from the vertex is x minus 1 squared, and then plus k, and we know that the optimal value is 240.1. Next step is to sub in any other point, so I can choose this point or this point, and they are our x and y values, so I'm going to choose 8 and 0, and that's going to give me 0 equals a, 8 minus 1 squared plus 240.1. Next step is to isolate, so we get 0 equals 8 minus 1 is 7, 7 squared is 49, so we get 49 a's, plus 240.1. We are going to subtract 240.1 from both sides. That'll give us negative 240.1 equals 49a. And the last step is to divide both sides by 49. We see that a is going to equal negative 4.9. So therefore, the equation for this parabola in vertex form that represents the path of the ball is h equals negative 4.9 t minus 1 squared plus 240.1. Using this model, we can determine the height of the ball relative to the ground from any time from 0 to 8. So we can see in summary, if you know the coordinates of the vertex and one other point on a parabola, you can determine the equation of the quadratic relation using vertex form.